In this particular question, we have two coins that are tossed. Okay, so we've got two coins and we need to write them out in a probability table. So we're given this here where it says there's some variable x, and then we can have a couple of things in here, HH, HT, or TH, and then the last column is going to be TT. So what does all of this mean? Well, first of all, it means like what's the probability that we get two heads in a row, okay? And then finally as well, we have this thing here that says the probability of x is equal to a little lowercase x. So I'm just going to write that out because I always seem to run out of space. So it just says, what's the probability of the big X it being equal to this value here? So big X is like your variable, and you're saying that's equal to heads. So the first one's going to be nice and easy. If we think about it, it's the chance is going to be 1/2, right? So it's 1/2, oh, apologies, times by 1/2. And so that is just going to be equal to 1 and 4. Okay, let's say you're not particularly good with math. You've got this thing called a calculator because it is a calculator assumed section. So what we can do is say 1 divided by 2 times by 1 divided by 2, and then that'll give us this answer here. Now, if you want to write that out in a little bit of an easier way, give me 1 second. Keyboard, you can write it out like this. Okay, and so that will give you the same answer. But let's say I like it in fractions. I can click that button to change it and it becomes 1/4. Cool. All right, so that's the very first answer here, 1/4. And that's the same for tails. All right, now this next bit, it's going to be either heads tails or tails head, right? So to make that easier, you can say that it's head tails, right? The probability of head tails is always again that 1/4. So we've just done the maths. The probability of tails head is going to be 1/4. So you can add them together, right? Because it's or. So when you say in maths, if it's or, it's plus, okay? And if it's and, it's times. Okay, and so when we add them together, let's say you're not particularly good at fractions, so 1/4 plus 1/4, they have the same denominator. So they can split across, and it becomes 1 plus 1, which is going to be 2 divided by 4, and that is equal to 1/2. But you've got a calculator, right? So let's figure out another way of calculating that, and that is that all of the probabilities have to add up to 100%. Okay, so we've got 100%, let's say 1, and we can subtract 1 divided by 4, and again 1 divided by 4, right? These two values, and then that should be left over here. That should be 1/2. So there you go. That's your answer there. So that is the answer to part A. It's pretty simple. You probably don't need a calculator, but it just makes it a bit easier. Okay, so the next question is asking what happens if two coins are tossed 50 times? Okay, so you toss both the coins, right? You toss them and you do that like times 50, right? Okay, what's the probability that two heads appear 10 times? Okay, so what's the probability that we get heads, right, 10 times out of those 50 trials? So this is important. It is a binomial probability problem, okay? You've either got this thing here, which is going to be your success, like what's the probability that both of them land on heads? That's considered your success. So we go back to the table and we can see that the probability of heads is this. So it's going to be 1/4. All right. So now what's the chance of doing that 10 times out of 50 tries, right? You can use the equation, but here you have a calculator. So we're going to use the calculator here. So the probability of x is equal to heads is going to be equal to 1/4. That's our probability of success. Okay? We're doing the trials 50 times and we want to get 10. So if we go over to the calculator, we can say we are going to go to interactive distribution. It's discrete, right? Continuous is like decimals. But we're talking about coins. You can't have half a coin. And we're doing what is the binomial PDF, right? So how many do we want to have successful? We want to have 10 of them successful. How many trials do we have? We've got 50 of them. What's our probability of success? Well, it's 0.25, right? And what you can do is write this down. So you can just write this down, binomial PDF, and you can write 10, 50, and then a quarter. And then you can say use calc. And your answer can be equal to 0.0985. So we can just say that's equal to 0.098. Oh, that's an 8, I promise, and 5. And that's the probability, right? That's good enough. That's all we want. Okay? And so now let's go on to part C. All right. This one's asking, all right, if those two coins are tossed, but they're tossed 50 times, what's the probability that two heads appear between 10 and 40 times? So what's the probability, right, that you're going to get between 10 and 40? Okay. Now, when you have lots of different things, like you could repeat the same thing, right, with like 10 and then change this guy here to 11, then change it to 12, and then keep changing it, keep doing it, and then eventually add them all up, right? We can add them up because it's the word or, all right, between 10 and 40, so all of them, and that's a pain in the ass. Like, that's too much to do. So if we go back to the calculator, we've got a special function for this, right? And this is interactive, same sort of thing, it's discrete, but it's a cumulative, CDF, cumulative. So the lower boundary is 10, right? So we're okay to get 10 heads out of the 50. Also 40 heads out of the 50. And we've got 50 trials. And again, our probability of success is at 0.25. And so now it's that 0.8363. So what you can do is just say B CDF and then put all the numbers in. And say use calc. And then say that's equal to 0.836 ... and I'll just say that's approximately 0.836. Okay, so that's the answer to part C. Okay, so now we go on to part D. All right, and this is asking if two coins are tossed again, so we've got our two coins and we're tossing them another 50 times, what is the probability that there is at least one tail? All right, 30 times. At least one tail 30 times. So what that's going to be is the probability of, we're okay with getting tails than heads, also heads than tails, right? But then also tails and tails, all right? And so we know these two combined, because that's in our original table, and that's 1/2. And this one is 1/4. So to find this probability, the probability of success, we have to add them together. Let's use our calculator because it's easier. So if I say 1 divided by 2 plus 1 divided by 4, that's equal to 3 divided by 4. So that is equal to our probability of success. Okay? And so again, it's asking us like at least one tail, right? Okay? So what we can do here is it's going to be between at least one tail, at least 30 times in 50 tosses. Okay, so at least 30 times. And if we figure that out, right, the probability of getting at least one tail in that 30 times is binomial CDF. So we use the CDF function and it is 30 times, right? Oh, sorry, it's the PDF because it's, oh, sorry, at least 30 times. Sorry, that's kind of confusing. So the lower bound is 30, the upper bound is 50, because we're okay getting like 35 tails at least once, or like, I don't know, 49 tails in there. And the probability, or the number of trials we have, is 50, and the probability of success in this case is going to be at 3 divided by 4. Okay, again, we're going to tell the marker that we're going to use the calculator, and then we're just going to go ahead and use the calculator here. So interactive, distribution, discrete, binomial, CDF. Our lower bound is at 30, our upper bound is at 50. We've got 50 here, and the probability of that success is 0.75. And when we run this, it's going to give us a very, very high number, 0.9937 forever. So we can say this is approximately equal to 0.994 and leave it at that. Okay, and so that is our final answer. Hopefully that makes sense about using the CDF function and the PDF function. That last question was a little tricky, I guess, because the wording, having it say at least one tail at least 30 times, the double at least is a bit confusing. But hopefully that makes sense. If you have any questions, write to me, leave some comments. We're really happy to help.